Now, one idea that this leads to is the idea of implicit differentiation. Now, I know that sounds really complicated, but it's basically just derivatives, but instead of for functions like f of x equals something, it's for things that include both x and y. So if you remember from Algebra 2 when we learned conic sections, let's say we had something like x squared plus y squared equals 9. It's just a circle with radius 3, something like that. Now, this is not a function because, as we see, it doesn't pass the vertical line test. These vertical lines don't only have one value corresponding to each x value. But we can still take the derivative. Like, if we look over here, a tangent line still exists. So how do we find it? Well, we start by just taking our definition of how we write a derivative. So dy over dx. That's the derivative of y with respect to x, right? So when we take derivatives, we know we can just take the derivative of x normally. So that'll be 2x plus, and 2y is a little bit different. So y itself is a function, right? Like, that's what it always is. F of x and y are usually interchangeable. So it'll be 2y, but because y is the function, we have to multiply by its derivative. But what's its derivative? Well, it's dy dx. By definition, that's what dy dx means. It means the derivative of y with respect to x. So times dy over dx. And then equals the derivative of 9 is 0, because it's a constant. And then if we rearrange the equation a little bit for dy over dx, we get negative 2y dy over dx equals 2x. And then we end up with dy over dx equals negative x over y. Now, something that I should have shown a little earlier is how to use the derivative to find the tangent line, not just the slope of a tangent line, but the actual equation for a tangent line. So let's use this as an example. So let's say we wanted to find the equation of a tangent line at the point 1, 3. Okay, well, first we plug in 1 and 3 to the slope because it's dependent on both x and y. So x is 1, so it'll be negative 1, and then y is just 3. So negative 1 over 3. That's the slope of your tangent line. Now, to write out the equation, we just go back to point-slope form from algebra. So it's y minus y1, which is 3, equals negative 1 over 3, x minus x1. x1 is 1 here. And then when we rearrange a few things, we get y minus 3 equals negative 1 over 3, x plus 1 over 3. Then add the 3 to the other side, and we get y equals negative 1 over 3x plus 10 over 3. Then this is the equation of our tangent line, not just the slope. This gives you exactly where it is as well as its slope.